Hi, I'm John, and I was bullied in 2nd grade because I didn't speak English. Now, to make sure that my child doesn't get bullied, I'm going to make him cooler. But to be absolutely certain that he doesn't get bullied, I'm just not going to send him to school. Because I'm 19 years old, and my child is a 3D printer. Let me introduce you to my child, but also please excuse the terrible, terrible impressions.
What, you're done already? You've only been here for like 15 seconds and I was talking for half of that. What kind of plumber are you? A printer plumber? Perry the printer plumber? Perry the printer?
So the actual reason I'm upgrading the fans in my 3D printer is that if you have a better heat break fan, you can print at higher temperatures and prevents heat creep. And if you have better part cooling fans, you can print at much faster speeds because the part cools faster as you're printing it. Now this requires that you have a stronger heat break fan and stronger part cooling fans. The part cooling fans, for my case, will be the blower fans that I bought last time.
The two blower fans. Blower? I hardly know her.
Now I won't explain what heat creep is yet, but I will tell you that it does bite me in the ass later. So after last month where I upgraded the motherboard, I wanted to see how good this upgrade is, and it's to see if it was actually worth it or not. So I did a test print. Being, the most standard test print is the Benchy, so I did that. I did a test print, and then I realized, it looked bad. You can see that it's bad, but I had no idea what it meant. So, everyone that got stuck on Who Wants to Be a Millionaire, I phoned a friend. And he said that it was either because of insufficient current in the stepper motor, or the printed filament isn't cooling fast enough, and that's why it looks like that. What piqued my interest, though, is the motor current. So I looked a bit into it, and it turns out the higher the motor current, the more accurate the positioning is. But then I also pointed out that it might be because the file is too small, so I asked if that contributed to a problem. He said it may be. So then I did a second test print where I made the file a bit larger, printed at 195 degrees Celsius, so maybe it can cool faster. And 195 degrees is 10 degrees colder than what I usually print at. But the print failed because I forgot to clamp the bed. But the first 7 layers of the Benchy still got printed, and I looked at it, and there was really bad fringing on the overhangs. And Google said that that's likely to be a cooling problem. So then I did a third test print where I increased the cooling, and it looked so much better, which means the problem was most definitely insufficient cooling. This is still with the stock toolhead, which is what we're modifying this month. So then I did a fourth test print where I increased the motor current from 580 milliamps to 630, and it showed little to no improvement. If I put the third and the fourth test prints side by side, you would not be able to tell which one's which. That's kind of the extent of testing I did with the motherboard. I did do some support tests, and I found some settings online, and they were amazing. I'm going to try and find a link to that post. Those settings were amazing. They worked like a charm. When I was printing some parts for this video, the supports came off so cleanly. It was beautiful. But anyways, back to the toolhead. Hi, this is editor John. I have no idea how to put this video together, so I guess I'm just going to go through the story of this part. So the original plan this month was to basically model everything, to have the extruder on there and have to have BL Touch installed. But some problems came up as I was designing these parts, and I realized I have to focus on the fans first. So first part we have here is this orange part in the center. So basically I started with a mount that would connect the entire thing to the Ender 3. These are the holes that correspond on the toolhead attachment mount on the Ender 3 Pro. And this is kind of where the heat break or the extruder assembly or the hot end assembly, whatever you call it, this is kind of where it would be installed. So then after that I lofted out this bell looking thing to, redirect air from the main fan, the main axial fan at the front, into the heat break. And then I shelled it out so the air could actually flow. So after I made this bell, I made a really rough model of the front axial fan, the 5015, which is a surprisingly large fan. Like, I know I held it in my hand while I was designing this, but I never really considered how big this entire thing would be until much later. So then after I kind of modeled out the fan, I was thinking how I would attach it to the main thing. So then I gave it, a little this, which is just a mount for the fan. Now you'll notice that these swept cuts, they don't have screw holes, and that is where we go into the next part. So this is the rough model of the front axial fan I was talking about. It's just 2 commands. I did an extrude and I cut it out. Honestly, could have been 1 command, but I was doing things a bit slowly and out of order right now at this point. And then there's this part. This part is this part. Basically, these mounts will be attached onto the main fan, the front heat break fan, and then that enables this whole thing to be slid into the main assembly instead of having to unscrew everything every time I have to fix something. Now, I did not account for the thickness of the screw heads here. Doesn't make that much of a difference. So honestly, whatever. I'm not gonna bother fixing it because it's not worth the time. So a little funny thing about the main skeleton is I kind of knew where these had to go, but I didn't know how to attach them to the main body. So I kind of just did a floating extrude here, and then I tried to make these cuts while it was floating, but for some reason it would work on this side but not this side. So I bashed my head against a wall for a couple hours. Well, not just in one hour, and I realized why should I fight SolidWorks? I should just work with it, And I just attached so I just attached these flaps to the main body. But you'll notice these extrudes get in the way of the bell, because SolidWorks doesn't have any function that kind of limits these geometries. So all that I could do was cut it out, and that's what I did. So then after that I did a sweep cut, and then I cut a hole off the top for the filament to go into the hot end, and afterwards everything afterwards is for the side fans. I went through a couple iterations for the side fans, and the main problem I had with designing the side fans was I couldn't settle on a configuration that made sense to me and that I could easily work out in my head. So, what I ended up with was, surprisingly, the first iteration I modeled, but not the first one I had in mind. Originally, my plan was going to have the side fans attach right beside where this extruder motor is. The reason I didn't do that was I felt like the longer of a path the air had to flow from the end of the fan to the hot end, the weaker the airflow would be, or like the harder the fans would have to work to output the same flow. Which I'm not sure if that's completely true or not. I'm still learning. I'm still an engineering student. I've only just finished the first year, and fluid dynamics is a second year course. So I don't have that information just yet. I could just search it up, but I I want to keep some surprises for myself. First, to model for the side fans, I made these brackets. These brackets have a really weird geometry. This little extrusion is my fault. I already printed these parts, so I'm not going to bother with fixing it right now. This geometry is at a really weird angle, and the reason for that is the line between these two circles is not at a perfect 45 degrees with the horizontal. So that means I had to make this sketch, not that one. I had to make this sketch, copy it into a new part, which is this file, and then basically make this back tab and then extrude it off of that. That's how I made the side brackets. So after I made the side brackets, I kind of just oriented the fans to be where I want them to be. And then I kind of just extruded these out, rounded out a little, made reference planes right here for the right angle, and just made a mount, which is it's not that, like, it doesn't seem that hard, but this is like the third iteration, which kind of sucks because I went back to the first one after iterating a lot, and that kind of sucks. I don't mind iterating if it gets me to a better design, but I absolutely hate realizing that the first time was right, or at least the first time is what works for me. And I say that because this absolutely could have been modeled better. And this design has some problems, which I will fix next episode. But for now, this is fine. So then, these green parts. This is what gave me the most problem. This is why I had to iterate the side mounts 3 times. First problem was I had no idea how I would arrive at this geometry. I would kind of just guess, honestly. And when I saw the distance between the nozzle and this fan, I kind of just didn't want to use this side at all. But after being convinced by a friend who was really knowledgeable about 3D printing, he didn't even have to convince me that hard. He kind of just said it, and I was like, oh, okay, whatever, fine. I'll do as you say, because he is, compared to me, an expert. A little thing that I forgot to mention earlier is after I modeled these mounts for the front fan, I did a little test print. But those prints failed. And now, we are now reporting to real-life John, telling us what happened. Alright, so, if you kind of understand what's happening here, mid-print, this thing popped out. So I'm going to have to fix this. I'm going to have to, I guess replace this whole thing. I mean, I'm going to replace this. I was going to replace this anyways. What I actually need to do is, I need to keep that away. I don't want to have to duct tape you. Just a temporary thing. What I need to do is, I have to change this out. But first I have to pull the filament out, and I probably have to do something about this. The thing with this, though, I don't need this whole segment, but I might as well just, like, cut... Oh. Yeah, I might as well just cut this whole thing out. There you go. I'm going to take this out, change out the thermistor and the heating element, and pull this out first, actually. So that means I have to turn on the thing. Alright, so I'm a very big dumbass. I immediately just touched the hot end and I burnt my finger. Alright, let's remove the nozzle. Hi, Editor John here. Yes, I did burn my finger the second I could. The reason I'm replacing the entire hot end assembly is I bought a hot end, an all-metal hot end upgrade. So if I'm going to upgrade the hot end, I might as well replace it now when the opportunity presents itself. Now, the old hot end clogged due to something called heat creep. Heat creep is when you print without sufficient cooling in the hot end. And what happens is, as you're printing, the heat slowly creeps up on the hot end. And what happens is, in my case, over a really long time, the heat slowly deteriorated the Teflon tube inside the stock hot end that came with the Ender 3 Pro. Now, heat creep is still a problem I dealt with the all-metal hot end. And the reason was because I was printing without any hot end cooling. If you recall, the stock hot end fan does not run at all. The reason is, I put a pin in there to stop it from moving because it wobbled really badly. The reason it wobbled a lot was because I broke 2 of its fan blades. So the entire fan is very off balance and I didn't have a replacement. But this one time I went down to the basement and I found the motherboard cooling fan to be disconnected. And I realized if I'm going to solder the fans anyway, I might as well replace the hot end cooling fan with the completely fine motherboard cooling fan. So I swapped those two, and now I have a mostly functional toolhead. And this is why I realized I had to lock in on the cooling part and just abandon the extruder and build touch upgrades for now. But anyways, back to the video. The thermistor is stuck in here instead of being just screwed on. I have a thermistor replacement, but let me show you what the problem is. It's behind all of those boxes, of which it's not even my stuff. Hi, it's me, Editor John again. Yeah, I should really get better at filming these videos so I don't have to cut in every time I'm editing. So basically, the thermistor is stuck in the heating block because really old molten plastic over the last couple of years, I just couldn't get it out. So then what I did was I found thermistor replacements that I ordered a couple years ago, and I snipped the wires connecting the old thermistor to the motherboard, which made the entire printer shut down because you would want to design it that way for safety reasons. So, to install the new thermistor, I had to sit down and basically install the new thermistor. To finish installing the thermistor, I had to unwrap the woven wrap that contains all of the wires going from the motherboard to the tool head. And it took me a really long time. Well, not really, but it took me a while to get all of that done. And while I was getting all of the wires back in the wrap, I don't know, I spent like 20 minutes doing that. And I talked for the entire 20 minutes. I wanted to time-lapse it. I could have time-lapsed it, but I talked for the entire 18 to 20 minute duration of it. So instead of trying to shove that clip into this video, which this video is way too long already, I'm going to publish it as its own video. I'm going to edit it a little bit so it's a bit more interesting to watch. And yeah, it will be released with this video, hopefully. If not, it would be the week after. So if you want to watch me lose my mind over the course of 18 to 20 minutes, feel free to check out that video. Okay, thank you, Real Life John. This is time skip number whatever, and how I ended up arriving at this geometry was, you'll see these 3D sketches. I sketched from the center of these nozzles, kind of to where this hot end ends. A couple problems I had with that. First problem was I had no idea how to connect these nozzles to the fan. At one point I considered zip ties, but you'll notice that there's not a lot of length on these nozzles for me to zip tie anything. And then my second option was friction fitting, but I didn't trust myself or friction fits that much. So then eventually I figured out that I could just draw a line to reference where this circle was relative to the end of the nozzle, and then I made a little tab connecting this entire thing. Now this seems very obvious to be the right solution now. That wasn't very clear to me when I was modeling this. These two nozzles took me an entire day of actual work to get done. And another problem I faced was I modeled things wrong quite often. At one point, the center of these nozzles were pointed at this line instead of here. And what that meant was these nozzles will be interfering with the print as it was printing. And I'm glad I caught that early on. But it was stupid of me to have ever done that in the first place. So that is pretty much all that I did this month in terms of modeling. Next month, hopefully I'll be done with this project, because goddamn, this is taking me way too long. This was supposed to be done in the first month. It's been 2. But whatever. Next month we'll be attaching the extruder motor so we can have a direct drive tool head, and we'll be adding the BL Touch. Now anyways, to see the real life version of this, let's switch to Real Life John. Alright fellas, this is everything printed and assembled. It's a bit wobbly because it's not supposed to be like this. It's supposed to be like this. This is pretty big. This is a lot bigger than I thought. For reference, this is the stock tool head. This is the upgraded tool head. It's so big. Also, that might be a problem attaching this to that, because the X stop does have the X stop does protrude out a little bit. Hopefully that's not a problem. Okay, so I have some pretty bad news. It does interfere with the X stop, but I do want to show you how cool this is. I could just pop things out. That is so convenient. This other side is not as convenient because the screw's not flush. I'll just like cut out a channel or something for it. But the problem is mostly this one. That is next month's problem, because I really have to finish editing this video. What quick joke can I end this video on? I'm not sure, but what I am sure is that this thing is massive. And you know what else is massive?